Hello. We good? We're good. Hello, everyone. Yeah, we're live. Welcome to the Real Robotics University of Leeds Lab Live. Here at Real Robotics, we specialize in robotic systems made to access hard-to-reach places to survey and monitor areas that are inaccessible for humans. Our current research is focusing on teleoperation. So teleoperation is essentially controlling the robot from a distance, but attempting to achieve the same level of interaction with the environment that a human would have if they were really there. Today, we're going to showcase this using our teleoperation framework by cooking and assembling a burger using two of our robot dogs. Both of these dogs have been kitted out with a robotic arm, which is mounted on top of the dog, and they can be remotely controlled. By working together, they should be able to create us a delicious meal, which for health and safety reasons, we are not allowed to eat. So let's introduce ourselves. I am George Jackson Mills. I'm a postdoc working on miniature robotics here at Real Robotics at Leeds. And I'll send you over to the rest of the group here. And they can introduce themselves.
My name is Joseph Humphreys. I am a PhD student focusing on low-level control for dynamic motion generation for Lego robots. Currently working on whole body control for teleoperation.
Hi, my name is Jingchen Sun, and I'm a first-year PhD student as well. And I'm currently working on jumping robots with gliding abilities. In this experiment, I will be the protector of robots in case of emergency.
Hi, I'm also a first-year PhD student. My focus area is shared autonomy and multi-robot cooperation, and hope everything goes well. We are planning to up here. There is a system initialized here.
Chris, our teleoperator, is just doing some final preparation, but he will be controlling our robots today to make a delicious burger, which won't be eaten. And yeah, so for teleoperation, he'll be using a combination of both a whole body motion capture IMU suit with one arm active and a joystick controller as well. So the joystick controller will be controlling the dog, and the arm will be controlling, well, the robotic arms as well. Just bear with as we are currently struggling with some network issues.
So the robot arms that are mounted on these dogs are normally really complex to control. It'd be really difficult to move both of these things using a standard gamepad or joystick. So here at Real Robotics, we've come up with a better solution, and that's to use a motion capture suit. And the suit is being worn by Christopher Pears, who is our top-tier, cream-of-the-crop robotics PhD student. And he's striving to become the best teleoperation chef in the world. He's currently out of shot, trying to get the demo working, having slight technical issues. I'm sure he'll make a dramatic entrance soon. So the technology he's wearing is actually a motion capture suit that is used to track actors' movements in CGI films. So it tracks a load of points on your body and records these movements. And then by using some of Real Robotics' very clever processing algorithms, we can then send Chris's real life arm movement to the robot arm on the robot dogs. So basically, instead of using these complex movements captured by the motion capture suit, instead of using him to turn Chris into like a CGI Spider-Man as they would in a Marvel film, we're instead using them to cook a burger using two robot dogs in real time. Very cool. I'm sure you agree. So this demonstration is going to begin anytime. Joey, maybe tell us a bit about your research. What's going on with Joey right now?
Okay. I am taking this system and basically adding a whole body controller to it. So essentially, we would get rather than having at the moment the system is controlling 2 robots, but the system another system on the side we're working on is controlling 1 robot, but going towards dynamic motion generation. So having a whole body controller optimize for a range of tasks, so desired characteristics that we'd want, and then the teleoperator would send a command to the robot, and the whole body of the robot would work towards realizing that command. It's a little bit different from this system because this system wants independent control of the arm and the base at different times. It also wants to be executing other dynamic gates as well. So we're not using it in this experiment, but in the future, this is what we hope to do as well.
Great, thanks for that. And can you tell us a little bit about the food we're preparing today, maybe?
Okay.
I'm not sure where we've got this burger from. Pre-cooked, is it? I believe.
This burger is in fact, yes, it's pre-cooked. This is a just a pre-cooked burger that you chuck in the microwave normally. So obviously we want to be working with any raw meat. So we've got a nice pre-cooked burger that we'll take from its starting position, pick it up, put it in the pan, shift it around in the pan a little bit, then transfer it to the burger bun, and then from there place the top bun on top of the burger, creating a full, nice little burger. We also have a nice little fire as well going underneath the pan. I don't know if you can see it, but we've got a nice little fire here. Lovely stuff.
Nice. Well, it's all looking great. The ingredients are prepped and ready to go. Any second now, Chris is going to come storming over here in his motion capture suit.
Yes.
Yeah, and he's going to make us a lovely burger. Any second now. So this kind of technology, I guess, we're showcasing right now a demonstration of how you can use it to cook a burger, but it can actually be used in all sorts of different circumstances. So instead of mapping your arm movement to cooking a burger, you could map your arm movement to turn a screw in an offshore oil rig, something like that. These robot dogs have been used in places like that where humans, you don't necessarily want to be. It's quite a harsh environment. You can go and do tasks that, simple tasks that a human would not struggle to do, but maybe would find difficult. And you don't need to send a human if you can send a robot. So we can place them with the robot dogs with a specialized gripper. But we could use specialized humans to control that gripper. So we get an expert in a teleoperation suit. We map them to a robot. We send the robot in instead of them. And it's just as good as sending the human, if not better, because you're not going to damage the human's arms, limbs, anything like that. There's no risk involved other than the potential loss of a robot. Another great area to explore would be inaccessible places, which is what Real Robotics specialize in, really. You could imagine creating a tiny robot to go into miniature pipe systems, really small, like 50 mil diameter pipes maybe. And you have it controlled by an operator that can then drive this robot to an area of importance that needs inspecting, repairing maybe. And they can perform their tasks in a place that a human wouldn't normally be able to be. And in environments like pipelines especially, you can have really high pressure systems that you wouldn't be able to go in without flushing the pipes. So you wouldn't be able to go into a live gas pipe as a human without completely shutting down service to the entire network in that local area, at least. So we can send robots in live conditions like that and have a specialized operator access small places, and we can save a lot of hassle on the consumer end. Conditions where you'd have to dig up a road, maybe replace a gas pipeline. So instead of digging up the road in multiple places, say like every single housing connection, which is currently what they do. That's why your gas works take so long, right? Because they come in, they dig up in front of each house, they find the connection to the mains gas, and then they repair your connection. Well, we can send a robot in, teleoperated, and we can inspect and repair those maybe in one excavation. You only need to dig one place to access the pipe. Send a robot in, does all the connections in one go throughout the pipe, and then comes back out the same hole. So it's things like that can really improve the efficiency of the way we work right now as a society. I think there's some action in the robot dog area. I saw a robot arm move, and I'm sure all 9 of our viewers are as excited as I am to see what's going to happen next.
Wow, nice little homing function.
That was the homing function, which means the
It's a technically a sleep homing function. There's 2.
it's a sleep
So nice little sleep thing.
a sleep function for the arm there. Oh, it's waking up again now. You can see it opening the gripper. Can we get a close up of the arm? Can we get the do we have any GoPros that we can get in there? Whoa, who's that? It's the one, the only Christopher Pears, top tier robotics researcher right here. He's extremely tired. He's been working on this code all day. Right, let's see what you can do, Chris. You gonna make us a burger? Yeah. Here he goes. Oh wow.
We give the robot the spatula.
So we're just getting our assistant here to pass the robot the spatula. Very important part of robotic burger flipping is using the correct tool. And here we go. This is the big moment. I've never seen such concentration on Chris's face. You can see right now, oh, there we go. He's got the burger. If you look in this view, you can see that Chris's arm is actually being copied by the robot arm on the dog. So when Chris moves his arm, that action is replicated on the robot dog, allowing him to beautifully place that burger into the frying pan. He's now moving the smaller A1 robot dog into position. This one is going to cook the burger. It's going to shake that pan about. The vision sensors that the robot's currently using are Chris's eyes, I believe. He's doing this by sight. Chengzu would like to know if we could see the burger closer. Chengzu wants to inspect the quality of the burger. Can anyone get a GoPro any closer to the station? I'm not sure if that's the one connected to mine. It's not got a very long lead. Anything longer? Just move one of the laptops. Ooh. So right now we're going to get the. Oh, Chris has run off. But when Chris comes back, we're going to get the burger out of the frying pan, I believe, and onto the bun. that the robot dog has just dropped the spatula. Our assistant is putting the tool back. I'm not sure where we are with that close-up, Chengzu, but Chris has assured me that it's only the highest quality ingredients have gone into this burger. Not that we're allowed to eat it. Bit of a technical error there. What's just happened there, guys? Can we explain that for the viewers? We crashed the arm. This is a pretty normal operation procedure for the robot dogs. So what would have caused that error, guys? Maybe we could explain that. Something of interest. So that was a motion capture suit connection error. Basically, the motion capture suit attached to Chris has just lost connection briefly. And there's high latency. It's the ping. The ping is too high. And basically, the messages are taking too long to get to the arm. And when that happens, the arm just goes into a sleep mode, floppy sleep mode. The robot's now equipped with the spatula again. I believe when our star player comes back to the chair, we can get this burger on some buns. Isn't that right, guys? Yeah. How's that close-up coming, guys? Any look? We're trying to set up another computer for the close-up, Chengzu. I'm really sorry for the wait. I'll just leave that comment up there until we've fulfilled the request. Bilal says, "Don't burn the burger, Chris." It has been on there for a long time. Can we flip it around? Yeah, give it a bit of a shake. There we go.
Yeah.
It doesn't look like it's sticking yet, Bilal.
I don't think we're going for medium rare anymore.
Yeah, medium rare. Medium rare's off the cards, guys. I'm really sorry. If you like it medium rare, it's going well done by this rate. I'm sorry, Chengzu. Quick question about the buns, guys. Have we buttered the buns?
We have not buttered the buns.
There's no butter on the buns.
That would be a good idea.
And also, I mean, there's no sauce either, which is my concern. I know it looks quite quiet with just me and the robot dogs in this room, but I can assure you there's a team of 4 robotic experts working over there trying to get this trying to get this back on the road. Any questions in general? Here we go. I'll ask us some questions. Why not share your thoughts in the live chat or tweet us at Robot Lab Live? Or find out more about the Real Robotics Lab at realrobotics.co.uk. Hang on, I'll just make us another banner. There we go. I'm sorry to say that we are experiencing technical difficulties. Chris, could you share a bit of the inspiration behind the idea of burger crafting as a demonstration for your robots, please? I have a question from the viewer. Chris is a bit unavailable right now. Chris is quite busy, but Joey's here. Joey knows.
What's the question, sorry?
Joey, what made you come up with this idea for burger crafting to demonstrate the robots?
Chris. Actually, Chris would be more suited to this question.
Oh, Chris would be more suited, not Joey. Never mind. Hey, Chris. Hello. How did you come up with this idea, Chris?
So I got asked to do the live stream by my supervisor, and he provided no suitable idea, so I must come up with one myself. So I was rather hungry at the time, so I walked back into the lab and requested my colleagues' input whether I should make food with some robots, and they're like, yeah. And then there we go, burger craft.
Wow.
The burger idea was suggested by Steve in the meeting. Originally, we were going to make pancakes or something.
I remember the
So,
pancakes idea, yeah.
steak. But went with burgers, since it's a more recognizable food, I guess.
Right.
Hopefully the Wi-Fi.
Well, you heard it here first. A truly inspirational story behind Chris's demonstration choice. Let's go to our next question. Does this robot use custom motors? These robot dogs are from Unitree Robotics. So they are bought in, and one of them, the small one, the one that's handling the pan right now, that's completely burning that burger, that is an A1. And the larger one is their newest model, the Alien Go. They both have different payload capacities. What's the payload capacities on these, Joey?
So the A1 has a payload of 5 kilograms, and I think I literally checked yesterday, but I think the Alien Go has a payload of 10 while standing.
Wow, 10 while standing. That's a lot of burgers, Joey.
That is a lot of burgers.
That's a lot of
Maybe
burgers.
low when it's walking, though, the payload.
Yeah. Yeah, it is lower when it's walking, isn't it? So the robot dogs themselves, custom motors from Unitree Robotics, and then the robot arms use Dynamixel servos, which are really, really nice high torque servos, and they're very simple to control. Daisy chain them together, make robot arms, make all sorts. So that's what we've linked these together with. I think, has Chris made custom grippers for these?
Yes, Chris. Well, not for the VX 300 arm, but for the small pincher arm on the A1, there's a custom pan holding gripper that has been made.
Custom pan hold gripper.
Cooking.
Yeah, that's quite a novel output of this research, the custom pan gripper. If you're interested, I'm sure some merch will be coming up soon on the website. If you want a robotic pan gripper, maybe check later. We'll see if we can come up with anything. Oh, Bilal's asked, can the robot eat the burger? One of the main advantages of robots is that they do not need biological sustenance, Bilal. So while the robot could eat the burger, in a sense, you could swallow the burger and put it in a little pouch. I guess the robot could not digest the burger. So I believe we're up and running. Chris is back in his chair, and here it is. The big moment. We're going to flip the very, very overcooked burger. Chris might skip the flip today because he's feeling a bit delicate after the... Oh, my heart's going. I'm sure you can see on this view, Chris is concentrating, moving the arm. Sorry there, I believe I had 2 mics open. So the burger's now on the edge of the pan, and I'm on the edge of my seat. Here we go. We're using the second robot dog to push the burger. Wow. Just like they do in the restaurants. Here we go. Can he make the landing? He's made it very tricky for himself because he's not cut this burger bun in a perfect flat plane. There's a bit of bread sticking up on the side. It's not especially flat. But that's just Chris. He loves a challenge. So we've got the second A1 here. He's coming to help out, much like he would with two hands, assemble this burger. Chris is going to use his second robot dog hand to hold the bun whilst the alien go dismounts the burger. Oh, and he's made it. He's made it. Touchdown. Oh, and Chris is overjoyed. It's the final step here. Chris just needs to grab this burger bun. We're going to use the spatula with the A1. You can see this robot arm is mimicking Chris's movements with the capture suit as he drives his arm forward like this underneath the bun. Chris has like motion controls, so when he closes his hand like this, he can control a certain axis of the robot arm. So to activate the robot arm movement by linking it to your arm, you close your fist and then move up and down, and the robot arm will move. And then if you let go, it'll stop tracking your movements. So you can be free to move your arm back into a suitable position, and then grip again and move. So the kind of motion is like a grip and push, and it moves the arm. We're getting really close to a completed burger. Wow.
Let's go. Let's go hand for Chris.
Everyone, a round of applause for Chris. Oh, good job, Chris. How are you feeling? Can we have a post interview? Can you explain to us how that went? How did that make you feel? Are you ready to do it again for the next demonstration?
Hopefully the latency isn't as bad. Maybe the motion capture suit isn't as buggy. It worked once. I'm guessing it'll work every other time we do it.
Yeah.
As usual. So very optimistic.
He's very optimistic, guys. So
I guess we start the Q&A. It says mic is muted at the top.
no, that's my mic. I know what I'm doing, Chris. I'm a professional. Let's answer some of these questions quick because I think we're going to run out of time. Could a drone help to cut the salad? I believe that's certainly possible.
Yeah, we could get like the robot arm to hold the drone and use the propellers as blades. Yeah.
That's genius. Yeah, you hold the drone, use the blades, chop up the lettuce. I'm not sure about tomato. You need quite a high torque rotor to do that. Thanks for the question, Rob. What are things that you could added additionally to your Unitary robot to perform the burger task?
So the A1, we customize the gripper so that it holds a sort of cylindrical object, and then we just bolted the cylindrical object to the frying pan. This is mainly because the robot arm we're using for the A1 doesn't have enough motors to turn in sort of the degrees of freedom. But we cannot move the frying pan in sort of. Actually, no, that's not the reason. The reason was the payload. So neither of our arms can actually pick up the frying pan So the frying pan is about 0.7 kilograms, and the big arm that we have on Alien Go can only carry half a kilogram. So neither arm could feasibly pick it up. So we had to find another way, and that way is to basically put the end effector manipulator around the handle, and then we just use the quadruped itself to drag the frying pan, as you saw.
You don't often lift a pan in a real restaurant anyway. So let's do the next question.
Where's the cheese?
Where is the cheese? Where is the cheese?
So we abandoned the cheese because when we did a rehearsal, it was too long. It took quite a bit of time for the burger itself. So the cheese would sort of be the same way we pick it up with the burger and the bun, with the spatula, with the A1 hand to kind of act as a counterforce. So I thought, since we're low on time, kind of dodge it, but essentially it'll be the same way as picking up the bun. So it'll be nice in that sense.
Yeah, I'm quite disappointed at the lack of cheese as well. Maybe in future work, next version, cheese, lettuce, tomato. Bilal says, well done. Thank you, Bilal. How does the burger taste? I'm very sorry, but we're not allowed to legally eat the burger for health and safety reasons.
Yeah, we disinfected the burger as well, so it's wise to.
It's a disinfected burger, and it's not suitable for human consumption. But maybe future work. Thank you, Andy. Great. So
That concludes the first session,
I
right?
guess that concludes the first session. Yeah. I should take my banner off that says we are currently experiencing technical difficulties. Thank you all for watching. I'm going to end the broadcast now. Thanks all for all your questions and sticking with us throughout this this trying times. Right. Okay. So I'll see you for the next loop.
You're supposed to put the holding slide up and mute everything.
Okay. Thanks, Chris. Supposed to put the holding slide up and mute everything. Probably mute first because they can hear us saying this.
Okay.
Okay. Bye. Now? Hello? We good now? Oh, sorry about that. One of our mics, the fancy mic's gone. Anyway, I'm George Jackson Mills. I'm a postdoc working on miniature robotics here at Real Robotics in Leeds. And I think we should introduce the rest of the team. Do you want to come round? Do you want to come round here? The no sound was an old comment, Chris.
Hi everyone. My name is Joseph Humphreys. I am a PhD student currently working on low-level control for dynamic motion generation in legged robotics. Currently, my work is to do with implementing whole body control in teleoperation. Yeah, that's about it. If we want to get you up.
Hi, my name is Yu Hui. I'm also a first-year PhD student here at Robotics Lab. My focus area is multi-robot and shared autonomy. Basically, how like one person gonna control two or three robots together. And currently, I'm working on the evaluation for human-robot interaction at this point. I will go to Jin Chen.
Hey, my name is Jing Chen here. Can you see me? Okay, I'm just gonna be standing. My name is Jing Chen Sun, and I'm also a first-year PhD student, and I'm currently working on jumping robots with gliding abilities. In this experiment, I'll be the protector of the robots in case of emergency.
Hello, I'm Christopher Piers. I'm a second-year PhD in the Real Robotics Lab. My research focuses are legged robots, teleoperation, and stuff like that. So I'll be teleoperating. Do you want to introduce her? So yeah, I'll be teleoperating the two robots today. Hopefully, we can make a burger under the 30-minute mark, unlike last time. Question. So it's like, what is the benefit of using a prototype robot instead of a burger-making robot? Well, the point of the demo is really to show the dexterity that can be enabled through our teleoperation framework. So really, when you have a bespoke burger-making robot, probably you're not teleoperating it, it's listening to set commands and like macros. And so with a quadruped robot doing it, sort of there to demonstrate that maybe one day you'll be able to send these two robots into, say, an abandoned nuclear reactor and make a burger there, or something else that requires a similar level of dexterity. So I will go ahead and make the burger. Thanks for watching.
Okay, so Chris is now going to use the small robot dog. It's a A1 unitary system with a 5 kilogram payload, and this one is going to be holding the burger for the larger Alien Go robot. So you can see here that Chris is using his arm to control the robot arm. So in a second, when he moves his arm, you can see he's gripping his fist, and that activates control for the arm. And now the arm on the robot dog is moving and mimicking Chris's motions. So we've got a question: do they have many burgers in abandoned nuclear reactors? Yes, actually, they have found Big Macs that have lasted that long. McDonald's have a special disinfecting method, so they can survive in nuclear reactors. Chris is just lining up the robot now. He's actually using this controller to move the robot dog's legs, because it's easier to move the robot dog with the control system on the gamepad. But the robot arm fully functional on his mapped to his arm circuit. So now Chris has got control of the Alien Go, which is the larger robot dog. So you can see here that this one's equipped with a specialized spatula end effector. And this end effector is going to be used to get right under that burger and put in the pan. Chris is just doing his warm-ups here. It's a really this is the motion suit recalibration, I assume. We're having some motion suit capture issues. So Chris has got to do his little exercises, and then the computer program has now mapped back to Chris's arm. So we're reconnected, and he's now connected to the Alien Go, equipped with the spatula. Chris is currently trying to use his arm to connect to the robot arm on the dog. We seem to be having some technical difficulties. On Chris's left in frustration. Well, this is quite upsetting. I know it looks like it's just me on my own now, but the entire team is over at the side, huddled around two computers, and they're currently trying to get us back online. Bear with us. What other dishes can the robot make? Joey, you got anything to add to that? Just shout. I'll reply with whatever you say.
Anything fried based?
Anything fried, anything with spatula. Hash browns, quite good. Eggs, very messy, but we can do it. Just drop the spatula. That's part of the calibration. Here's Joey placing the spatula back. Chris is back in his seat. Okay, we're going to try and reconnect to the arm now. I believe we have connection. You can see Chris is oh, it's not a good day for Chris today, is it? Well, it's frustrating. It's a difficult sport. It's a difficult sport, this. In the last lab live, we had quite a bit of trouble with the second step once the burger was actually cooking. But at least in this case, the burger is not being overcooked. The last one must have been extremely well done. It's still nice and safe on the side here in our food preparation area. You can see the robot dog just doing some arm calibrations there. Chris is off screen. Why did we choose robot dogs for this task? Joy, any
input?
Any input for why did we choose robot dogs for this task? Here you go.
Well, I think using robot dogs for cooking is just quite a cool idea, you know, and it gets to show, like, you know, how these kind of systems, although extremely complex, can also do tasks that are also quite dexterous as well. Through our teleoperation framework here as well. One thing to note as well, I don't know if George has covered it yet, but we are using a hybrid control system here, where we've got the controller for the arm and the controller for the dogs and the motion capture arm for the arms of the dogs. And yeah, so hopefully we'll be up and running soon again. Is there any other?
I guess I did forget to mention about the motion capture suit technology. I think that's because of the mic issues earlier. So the technology that Chris is using, these robot dogs, they have these arms mounted on them. They're quite difficult to control, especially if you're using just a gamepad or a controller or a joypad or something like that. So basically, instead of the gamepad, we have come up with a better solution, which is using a motion capture suit. So the suit is being worn by Christopher Pearce. He's our top tier robotics PhD student, and he's striving to become the best teleoperation chef in the world. This technology is pretty similar to the motion capture suits that you would use to track actors in CGI films. So it tracks loads of points on your body, and then it records the movements. But by using some of our real robotics, very clever processing algorithms, then we can send Chris's real arm data to the robot arm on the dog. Mayday, mayday. Send in the cavalry.
I think the dog had enough of cooking today.
Is he okay? Is he okay, guys?
I think it will do.
Oh, get him some water. So this can happen sometimes when the robot disconnects in an unexpected way from the PC that's controlling the dog, that's also connected to the suit. So especially with the latency issues that we are experiencing, something's happened there where we've disconnected from the robot, have we? Completely, and basically the robot collapses. It's actually fine. Like the robot dog, you can see it's standing up again. He's up. He's always getting back on his feet. The robot dogs, when they're on, they apply active kind of torque to their limbs. So they have to exert effort to stand up all the time. Their normal state is to go all floppy and loose limbed. So when they lose connection, when they have an error, they will just flop basically and fall to the ground. And it looks quite dramatic, but most of the time they're fine.
These are quite rugged. These are quite rugged robots. So, you know, they can take some falling and still survive quite nicely. As you can see, well, he's already back up at standing. The arm's taking a little bit of a rest at the moment. We'll get him up and running as well soon. Just while we're in, I guess, in some sort of little intermission, are there any further questions that we have or want to ask?
Are these robot dogs also trained on other tasks, like playing with a ball, entertaining a child, or security tasks?
Well, they could be. Currently, all we're doing at the moment, there is technically no training going on. They're just being used, you know, directly controlled by the teleoperator. So there's no sort of machine learning involved here. We can also, yeah, I mean, if we have Chris sat down controlling the robot, I'm sure we could get him to play ball. Although I don't know how good this this arm would be at throwing the ball itself. It would have to be a pretty light ball, as this arm has got quite a limited payload. And what else? I mean, insane a child. I don't know.
I think robot dogs are inherently entertaining
Yeah,
to children, aren't they? I
I'd
don't
say.
think you need to train them at all.
Yeah.
I'm entertained by the robot dogs.
Just happy to see them stomping around.
Yeah. They're just great fun, great to watch. Security tasks, I'm not so sure. I mean, if this robot dog was patrolling a building, I think the thief would be more likely to steal the robot dog than be deterred by it. So probably not the best choice.
I reckon security cameras, do a much better job of that. I reckon.
Security cameras are quite good. Guess I'll just do some more talking while Chris and the team are trying to fix our connection issues. Let's get the banner up. As is tradition for each of these broadcasts, we are currently experiencing technical difficulties. Please stand by. You're welcome. Any more comments from our viewers? Please ask us questions. Share your thoughts in the live chat. You can find more about our website, Real Robotics. You go to the website, have a look at our other projects. We work in pipe robotics, swarm systems, aerial robotics, 3D printers that we put on drones. We put out fires with drones. What else we do? Can you think of anything else, Joey?
We also are starting to look at dynamic motion generation for these type of robots on a low level. So I'll be looking at things like, say, whole body control or an NPC, for those that you know. But essentially, it's like all these things form part of a wider control framework to control these robots in much more defined fashion. So you can do things like perform dynamic gates, like a flying trot, whereas these robots, with the standard gate is usually just a little trot. We are also looking at jumping robots as well. We have one member of the team, Jin Chen, looking at a jumping robot that can then do a little bit of gliding after that. We're also looking at reinforcement learning and other such learnings to allocate tasks to different robots, and that's Yuhui's research. And yeah, although our main focus at the moment is this teleoperation stuff. And before we've used a similar framework, only using one robot, not two robots, to disarm a mock bomb at one point. That was pretty cool. Pretty cool.
That was cool.
Yeah.
Oh, here's a good question. How would you compare your experience of using a Unitree to if you had used a Spot? Chris would like a Spot Mini, wouldn't he?
Chris would love a Spot Mini, to be fair. Personally, I haven't used one. Have you used one, George?
I haven't used one. They look very cool. But Unitree's great. I mean, they're a lot cheaper, right, for a start.
Definitely.
And
Much
quite
more
nice for
affordable.
research, right?
I'd say so. Yeah. I think if you're doing, if you're using the Spot, as far as I'm aware, low-level control is not possible. So it would be okay with this kind of task, but we want to buy these, we want to get these robots in for doing
research,
yeah,
right?
exactly, whole
They're for
different things.
research.
So we want it to cover everything, low-level and high-level control.
Yeah, we need to hack the low-level control. If we can't do that, then they're not great for research, are they?
Although I would say, if for high-level control, Spot would be the best one around. I'd say so. But that makes sense.
They look amazing.
Yeah. Nice yellow colors as well.
Our robot, I assume you mean the robot dogs we're using. So they are. These are from Unitree Robotics, which is a Chinese company that make robot dogs. We've got two different types here. This is the A1 robotic. A1 robot dog is the small one. That's a 5 kilogram payload, and then there's the Alien Go, which is the large one with the spatula. The spatula is custom, does not come as standard.
In-house modified.
In-house modified, yeah. The robot dogs don't come with the robot arms. We added those. So those are custom Dynamixel robot arms that we built. but the robot dogs are available to buy. I can't remember how much they are.
Neither can I, unfortunately.
Neither can Joey. So we're terrible salesmen. Sorry about that.
Sorry, Tossing Robotics.
Will you be offering a delivery service for these burgers? Yes. We will be on Deliveroo, Just Eat. Unfortunately, the waiting times are quite long. It takes us quite a while to get the burgers out, and they're often cold because our fire is a piece of A4 paper. I wouldn't recommend them for human consumption. These burgers have been disinfected as part of health and safety, so they could be delivered, but I wouldn't eat them. What is the future plan for this project? Short-term and long-term, and long-term goals. Joey, maybe you want to go on that?
So I think at the moment we're using these two robots using a high-level controller. So as you'll notice, like we will just be controlling either the trajectory of the base to make them walk around, or we'll be controlling the arm. This is all done through higher level control. If we want to, produce more dynamic gaits, or we want to use whole body motion while the grip is trying to reach things, then we would implement some sort of whole body controller. So that would be because there's lots of joints in the robot, and we want to use all of them to improve efficiency, to increase the the range of the arm as well. And this is all achieved through whole body control. And then we could, expand this further, introduce something called an NPC, which is like a planner as well. And then, I don't know, say like a gate scheduler as well. Again, all forms part of this wider framework, which is seen in, more well-known robots, such as Spot. There's also like the high-level controller of these dogs also uses such a framework. But we would look to create our own framework in the lab, and then combining this with teleoperation as well would make a very robust system. No audio.
Battery? Did you press the button?
Nope.
Switch back to the
Mic's
mic.
on. Hello. Testing. Is the good mic working again? Is it working? Hello. It's working? It's got audio there. Oh, Rory can hear it. Thank you, Rory. Thank you. Would you consider making a robot dog of your own from scratch, having the knowledge of robotics design and prototyping? Thanks to the 3D printing. Yes. Yes, we are actively looking into creating our own robot dogs for the lab. It's something that we've wanted to do for a while. It's something that's quite a big investment time-wise, but it would allow us to completely redesign it and change the way the robot dog works without having to rely and break down other people's systems and code and reutilize those. So yeah, brilliant. Definitely the way we want to go.
Oh yeah.
Okay, I think we might have to end the stream there, guys. I'm very sorry that we didn't get very far with the burger. You saw the robot dog fall down. That's always fun. The burger will still be here for the next Lab Live. So maybe join us for the next session, and we'll have another go. Thanks for all your questions. Don't forget to check out the Real Robotics website. I've put the link on the banner below. And I'll see you in the next loop, maybe. Okay? Hello, everyone. We're back for the Real Robotics University of Leeds Lab Live demo. So here at Real Robotics, we specialize in robotic systems for hard-to-reach places to survey and monitor areas inaccessible for humans. And basically, we're now focusing on teleoperation, which is essentially controlling a robot from a distance, but attempting to achieve the same level of interaction with the environment that a human would have if they were really there. Today we're going to showcase our teleoperation framework by cooking and assembling a burger using 2 of our robot dogs. You can see the robot dogs in frame here. Joey's just resetting the arm there. And you can see our burger components. We've got a delicious looking burger patty in the kitchen there on the first plate. And then we've got our frying pan, which we're going to cook our burger in, give it a shake, and then we'll transfer it to the burger bun on the end there, and then complete the burger, which together these robot dogs are going to help create us a delicious meal, which we are not allowed to eat for health and safety reasons, unfortunately. So I'm George Jackson-Mills. I work as a postdoc here at the University of Leeds on miniature robotics, and the rest of the team are quite busy trying to get this demo up and running. So I'll just be talking here about what's going on, and if you can ask some questions as we go, I'll try and relay them to the team and get response to you as soon as possible. So Chris will be coming in to do the demo soon. Basically, these robot arms are going to be controlling. Oh, here he is. Look, he's sitting down. So here's Chris. These robot arms are really difficult to control. So if you use a joystick or a gamepad, you wouldn't be able to control 2 robot arms. So what we've done is we've mapped it to a motion capture suit. So here goes Chris in his motion capture suit. He's walking up with the robot dog. Basically, the motion capture suit works like a CGI suit in a film that tracks actors' movements, and then they use it in CGI to turn them into Spider-Man or whatever in Marvel films. But we're using the motion capture suit to map Chris's arm, and then we are translating the arm motion to the arm on the robot dog. So using that, we can grab the burger and put it in a pan and assemble a complete burger. Just one of the many applications for this technology. So Chris is working now on just steadying the burger for the other robot dog. So this is the small robot dog, the A1 from Unitree, and it is using. It's got a 5 kilogram payload, and you can see Chris's arm moving there. Basically, you can see him opening and closing his hand like this. So when Chris's hand is open, he's not connected to the arm. When he closes his hand, when he moves his arm, then it will move the robot dog. So what he does is he opens his hand, closes it, moves the arm a little bit, and then you let it go, you bring your arm back, then you can move it again. And he's just switched control to the Alien Go robot dog. And now he's leaving the frame. Presumably there's a control issue that needs solving. So it's controlled from a laptop just off to the side where Chris left then. So the laptop's tracking the motion suit. The laptop takes the inputs from the motion suit and then translates them into motor commands and then sends them to the robot dog. So Chris is currently editing something on the master control PC side. Yeah, so using this motion track suit, we can take some really clever algorithms that these guys have been working on, and we can send Chris's arm data live to the robot dog, which is amazing. So you can operate a robot dog with an arm from whatever distance you like, as long as you've got an internet connection. So it has really exciting applications, this technology. We can use it in all sorts of systems. You can imagine sending tiny robots into pipes that are operated by humans in real time. And we're also looking at integrating this with a virtual reality technology, so that the human operating the robot dog in this instance could have a camera feed on their goggles, allowing them to see exactly what the robot's seeing and perform these tests live, and in an environment that looks like where the robot is actually operating. I think we have a bit of action on the Alien Go. It's got its spatula out. So these robot dogs come from Unitree Robotics. They're off-the-shelf systems, but we've modified them with the robot arms. These are Dynamixel robot arms, and this Alien Go system has a gripper on the end effector, and is currently gripping a custom spatula, a very expensive robotic spatula. And what Chris is attempting to do now is to line up the robot dog with the burger and get the burger on the spatula. It's a lot harder than it looks. You've got to remember, this is early stage, low TRL technology, guys. It's cutting edge robotics, this. Don't forget, if you have any questions about what's going on here, then you can ask us questions, share your thoughts in the live chat, or tweet us at RobotLabLive with hashtag RobotLabLive. And you can also go check out the Real Robotics Lab, which is at the website there, www.realrobotics.co.uk. Still experiencing some technical difficulties here. It looks like I'm alone in the lab talking to a bunch of robot dogs, but there's a team of 4 or 5 people working off to the left of me trying to get these up and running again. Quite fickle things, these dogs, difficult to train. We really just need this connection back, and then Chris can start controlling them using his motion capture super suit. I have a question. I will get a resident expert to answer this. Are we using inverse kinematics to map the hand location to the robot hand? Joey, take the stage.
So, yeah. Is it not this one? Yeah. So we are using a inverse kinematic solver to transform a reference trajectory generated by the arm into a trajectory realized by the end effector of the arm. Yes, basically just yes. Just utilizing its Jacobian, if we've heard of that before.
Oh, great. Well, that was a very fancy yes. There you go. I hope that answered your question, Mo. Oh, the robot dogs are coming back to life, it seems. They're waking up. We just dropped a spatula. We'll get a technician in now. This is quite a technical task, this. You've got to place the spatula back in the gripper. If Chris will stop moving the robot arm.
Really don't think the Alien Go wants to make a burger today.
The Alien Go does not want to make a burger.
Everywhere.
So many burgers he's made today. He's tired, guys. He wants to go home. He's running low on battery. And there we go. We have a spatula again. Now that's progress. Are you taking vision feedback externally, or is it robotic arm for visual servoing? I think most of the vision feedback is through Chris's eyes at the moment. It's all line of sight stuff. But do we have plans in the future, Joey?
Not explicitly, but I think that is definitely a direction which we could take it in, where instead we do have the teleoperator located in a completely remote location, and they can only view what's going on with the robot through the onboard cameras, either situated in the the base of the robot itself or in the arm. And this could be done using a VR headset as well to make it more immersive and make like as if you were actually the dog itself, which would be very cool. Almost like a sort of like Power Rangers in a way.
Yeah.
But yeah, basically that could definitely form part of our future plan. Any other questions?
Yeah, it's a good idea. Oh, he's gone to sleep. The arm's powering down. Quite sleepy today, the robots. Sorry about that. Not sure how that happened. Oh, headphone connection to the laptop died, and then it blurted out of the speakers. Can we get any? Oh, another question. What is the communication interface? Are we utilizing ROS in this project? Yes.
Yes, we are.
Yes.
We've got a whole load of cross nodes set up. So we've got probably one for both arms and one for both robots. Communicates with each other. We also use it for collecting data as well for post task analysis. He really doesn't like that spatula. Anyway, but yes, this is primarily a ROS system, really, for communication, just because it's the best way to do so at the moment. And yeah, so currently the setup we have is the motion capture suit is run using a Windows computer, and then using ROS that then communicates with an Ubuntu computer, which then in turn sends all the commands to the robot. And it looks like a bit of lag there.
Sure.
Hey, sorry about that. We had some technical issues with the connection in this lab. Just dropped, and our entire broadcast went all flickery, including the connection to the robots. So I think we're having quite a bit of trouble here. So we're just going to answer these last questions, and then we'll sign off for this demo, I think. So since you said they developed the ARM, are you using the MoveIt framework for IK Solver for inverse kinematics? Are we using MoveIt?
No, we're not using MoveIt.
No, we're not. Can you please give a brief description about the motion capture suit and how it is integrated into the robot? So,
Do you want to,
Chris, do you want to come and talk about that? Because there's not much else to do,
Show
right?
them the suit. Be nice.
Come and show them the suit, yeah. Suit up, Chris. Here's Chris in his fancy suit.
Wait, what was the question? Can you have a brief on the motion capture suit? How's it integrated with the robot? Okay, so our motion capture suit is made up of these wireless IMUs, which are subject to wireless interference. So what happens is so I wear these like glowing green IMUs on each limb, including the glove, which is here. And what happens is we run the dedicated motion capture suit software, and it generates a skeleton of my body where each limb has a XYZ position and a roll pitch yaw. What we then do is we use ROS serial to transmit this to our Ubuntu setup, where we can then use this data for ROS. And what we do then is we turn it into TF format transform, which is pretty standard in ROS. Then, using the TF data we've then generated, we calculate the relative positions of, say, our hand from our shoulder or spine joint. We use the spine specifically because the spine rotates with the body of the human. So essentially, no matter where you wear the IMU suit or where you, what's the word, recalibrate it, you'll still obtain the same data. And then we obtain the relative positions, and then we assign a trigger to it. So these triggers can either be, say, a trigger on a gamepad or a button, or say the hand's closing. And then when this trigger is activated, we essentially take where the location of the relative location of, say, your hand is, and then we use that as like a separate origin, and every movement from there subsequently becomes this XYZ transform from that point. We then we take, say, the X magnitude that the hand has moved, and then we assign this to the robot, and it will move forward. And we do that for the primarily for the arm, since the robot is. Why didn't you use off the suit motion capture suit? Wait, go to the next question. So this is a off-the-suit motion capture system. I believe the one we are using is a perception neuron. However, ours is rather old, and it's a legacy suit now. So we have some issues with the hardware itself. Yeah. So no, we didn't build our own. I think the difficulty with building our own is the kind of collaboration of all the IMUs together. This is probably pretty difficult, and this is why suits that are on the market are selling so well, I guess. Yes. Any more questions?
Great. Thanks, Chris. I hope that answers your questions. So for now, we're going to sign off, and then hopefully we'll come back with a clip of the robot dogs working in a previous lab life example, because currently it doesn't look like we're going to get moving again. So sorry about that, guys. Thank you so much for all your questions. And if you want to find out more about robotics, you can go to the. Thanks so much for watching. And hopefully, if you want to see the robot making the burger, you can stick around for the clip afterwards. See you soon. Bye. Thanks for watching.